Hi everyone, I am Ramkumar. Welcome to my channel. In the previous topics, we have discussed about software engineering. So, now we are going to discuss about software cost estimation and risk management. So, let's dive into the topic. So, generally, what is software cost estimation and why cost estimation should use in software engineering? Generally, software cost estimation helps organization to predict the effort, time, budget required to develop software projects. Accurate estimation is essential for software planning, resource allocation, and risk reduction. In this presentation, I will cover empirical estimation techniques, different COCOMO models, and risk management strategies. Generally, a comprehensive overview of empirical estimation techniques. Generally, cost estimation is nothing but we have to find the cost, how the when we are going to construct a product, we have to estimate how much cost it is going to be and how much cost it there is a chances to spend, and how much time we have to spend on the project. Like that, we estimate cost, effort of the people, and schedule. So by estimating these three, we can also improve the quality of the product. These are the empirical techniques. Let us begin with empirical techniques. These techniques use uh, historical project data, previous experience, based on the previous experience or assumptions to estimate software cost or effort. There are three commonly used approaches. The first one is expert judgment, where experienced professionals provide estimates based on their knowledge. The second one is estimation by analogy, where we compare the current projects with similar past projects, etc. The third one is Delhi cost estimation, which gathers opinions from the multiple experts and reaches a experts from the organization, as well as the experts from the uh, teams, like coding team or testing team, or the experts in the same organization, or the experts from the other organizations, through structured discussions. Cost estimation refers to predicting the financial expenditure required for software development and testing. Several mathematical and practical models have been proposed for this purpose. Uh, these models are broadly classified into three categories: empirical estimation, which relies on historical data; heuristic techniques, which used practical problem solving approaches; and analytical estimation, which depends on mathematical and logical analysis. These are the three. And uh, in COCOMO model, uh, we have three basic models. That is basic COCOMO model, which approximately find the effort and cost of the project, and intermediate model, which includes cost drivers, and detailed model, pre-module estimation it is. So let's discuss the basic COCOMO model firstly. So here we can see the values that is given in the table. These values were identified by the experts who are in the starting level of the software industry. So they have fixed these values when we are finding the uh, estimating the cost. So this will be identified in three ways. That is organic way, and semi detached and embedded way. So three different ways are there, and we have the same example, and we are finding three different values. So in organic way, we will find the efforts of the person and how much time we can take. At the same time, in semi detached also we can find the people, and we can also find the schedule or months, how many months we can schedule. And in the embedded also we can get the same thing. So generally, the formula of the cost estimation was A into KLOC B. So here KLOC means the line of code. Based on the line of code, we can find that values. Sorry, we can estimate the cost. So example 33.2 is the KLOC, and we are going to estimate the persons, how many persons we are going to get, and how much time, the effort, and the time, and the people we have to use. So generally, person per month, or how much time they have to work, we will calculate based on that, right? So in the same way, we are going to identify a if one person we are taking, so one person should work how many months, so that is going to identify first. So here we are calling as E, we are denoting effort with E. Okay, so again, uh, so then the formula is A into KLOC into B. So here we are considering that in the organic way. So we are considering A is 2.4 and B is 1.05. Okay, so based on that, we are getting that 94.92, sorry, 92. So one person should work 94.92 months. Okay, so per person they have to work 94 months and 0.92 months. So now we are going to find effort. So the effort formula is C into effort D. Okay, so what is the C value? So C value is 2.5 and D value is 0.38. So 2.5 into effort, here effort is 94.92, right? So 2.5 into 94.92 into 0.38. So the total, we are getting, how many months we are getting? We are getting 14.1 months. Okay, so now we are going to find how many persons we need to keep in this project. So the formula is P equal to E by D. So P is E is the effort 94.92 and the time is 10.1. So when while we are dividing these two, we get 6.73. So uh, after decimal point, the value is above 5, that is 50. So if the value is above 5, we can consider plus 1. Okay, so that's why here we mention 7. Okay, so now coming to semi detached, in the same way we are calculating, but the values will be changed. These values will be applied in the same formulas. Okay, so while calculating semi detached, one person can work 151.63 months, and the time should be 4.4925 months, and the person's need is 10%. Okay, so we need 10% to work in semi detached. In embedded, the same formulas will be calculated and these values will be applied in embedded. Okay, so here we will get 240.80 per month. One person can work to 240.80 months, and the time should be 14.4 months. We need effort for 14 months and the people need is 17. Okay, so this is the basic COCOMO model. So when coming to intermediate model, uh, we have considered that EFA. Okay, so EFA is calculated by multiplying the parameter values. So that will be collected from different cost driver parameters. So what is cost driver parameters? So here you can see product parameters, hardware parameters, and personal parameters, project parameters. So you can see four types of parameters, right? So these parameters is called as uh, driver parameters, cost driver parameters. So in the previous one, so we can see the table, right? So in the same way, we will have four different tables to estimate the values. So based on that tables we can calculate these uh, values in intermediate, these values in intermediate COCOMO model. So here we can calculate for 300 KLOC, that is 300 lines of code we are going to calculate, and the person will have having that very high experience and very low programming experience. So based on that, so while calculating this, uh, we have to identify the parameters that is very high, very high experience and very low programming experience. So the person is having very high experience and he is having very low in programming. So then we have to consider these parameters, that is personal parameters. So based on these parameters we are calculating this. So the values, how we are going, we are having these values and which values we are going to add, this will be explained in the material. So you can follow the material which was given in attached to this link, so this video. So you can get the values. So nothing nothing tough, you can see the values here, right? So in the same way you will have four different tables and you have to apply that values here. Okay, so now coming to detailed COCOMO model. Detailed COCOMO model is most comprehensive version of the model. It combines the concepts of basic and intermediate model and applies estimation separately to each module and development phase. The phase include planning and requirements, system design, detailed design, module coding and testing, integration and testing. The overall project of completion. Okay, for example, in a distributed management information system, the database module may uh, estimated using semi-detached mode, the graphical user interface module using organic mode, and the communication module used embedded mode. The total project cost is obtained by summing the estimates of all modules. Okay, so in this example we have three different types of estimations, right? One is semi detached and organic mode and embedded mode. So all the sum of these models will be the detailed COCOMO model. Okay. Then risk management is a semantic process of identifying, analyzing, and prioritizing and mitigating risks that may affect project cost, schedule, and quality of performance. Risks can be categorized into technical risks such as unproven technologies and system complexity, project risks including budget overruns and scheduling delays, people and process risks such as uh, skill gaps and communication issues, and security risks including cyber attacks and data breaches. The risk management cycle consists of four major steps, that is identifying risks and assessing that risks and prioritizing them and mitigating them through evidence and reduction, transfer, and acceptance, and finally monitor and review them continuously throughout the project life cycle. So we have to uh, monitor continuously until the project was completed. Thank you. So I hope you find this session good. So if you like my presentation, please like, share, subscribe. Thank you.